All right, guys. Hey, we're gonna look at the unit circle, and here is the unit circle over here. Notice it's basically on an XY axis. You see four triangles, but at any given time, you're really only focusing on one of these triangles. Let's make sure the language is clear. From in the first quadrant, that's from 0 to 90 degrees. So if you see a triangle in the first quadrant, those are the triangles that we've been looking at, the triangles that we just looked at from the warm-up. Everything we've been doing so far has been in quadrant 1. What makes today's lesson a little different is we're going to be looking at quadrants 2, 3, and 4. And one thing I want you to focus on is the fact that the hypotenuse for each one of these triangles, I should have written it down, but here's a chance to put it down, is that the hypotenuse is always 1. So let's label that 1, 1, 1, and 1. The hypotenuse is always 1 for any of those four triangles. All right. Whenever we're talking about the sine of an angle, if it's an acute angle, it's always going to be this angle here, or here, or here, or here. Those are known as reference angles. And we'll always need to find a reference angle when finding a trig function without our calculators by following these rules. Okay, we're always going to subtract from 180 or 360 degrees, never 90 or 270. All right. So let's make sure we know what the quadrants mean. Quadrant 1 means that it's between 0 and 90 degrees. So 0 to 90 degrees. And this is between. All right. All of these are between. So 0 degrees is not in quadrant 1. It's 1 degrees in quadrant 1, or 89.9 degrees is in quadrant 1. All right. But not, so it's 0 to 90, not including 0 and 90. Same thing. Quadrant 2 then would be from 90 degrees to 180 degrees. And then from 180 degrees to 270 degrees, and then 270 all the way to 360. Okay, so let's look at that. Here's 90. You know that's an L. Half a circle would be 180, but the 90 to 180 is the quarter circle here. That's quadrant 2. Quadrant 3 is 180 to 270, and then 270 to the 360s in quadrant 4. So depending on what your angle given is, you're going to need to subtract from 180 or with 180 or 360 to get these smaller angles. It's actually going to be really easy. All right. The other thing we have to know are the trig functions and whether they're positive or negative. So here's a quick explanation. Here are the two special right triangles we just looked at. Now, these triangles aren't always these special triangles, but just, it's the same math. It's just we're looking at the special right triangles because these are the ones that we can work with without a calculator. Now, notice the hypotenuse for both of these is 2. The unit circle, the hypotenuse is 1. So watch what I'm going to do. I'm going to take that and I'm going to shrink it by half. Right? That's roughly half. So the hypotenuse is now 1. And why is that important to understand? Is because, well, take a look. Oops, don't want to rotate it. If I take this and I move it there, notice if the hypotenuse is 1, does that change the trig value? And it actually doesn't, because what happens is if I want the sine of, let's say, 45 degrees, sine of 45 degrees, I can look at the special right triangle and it's like, oh, the opposite of 45 is root 2. The hypotenuse is 2, right? I know that. But guess what? If I made the triangle half the size, then everything is over 2. Right? Which makes the hypotenuse 1. Well, now if I say the sine of 45, well, it's a similar triangle. It got shrunk by half, but trig functions are a ratio, right? 2 over 1 is the same thing as 4 over 2 or 10 over 5 or 100 over 50, right? Like, it doesn't matter how big or small I make this triangle as long as it's a similar triangle. So what we've done is we've taken, see, if I look at sine 45 again, but now if the opposite is root 2 over 2 and the hypotenuse is 1, that's the same answer. I can actually just ignore the hypotenuse, right? Because now opposite over hypotenuse, here's the opposite. It's just root 2 over 2. So when I look at this unit circle, whoops, let me get rid of that now. When I look at this unit circle, you see how I made that red line there? That's the opposite for all the angles, right? So let me go back over here. So if I take a look at this angle right over here, the opposite side is here and the hypotenuse is 1. Well, that means some opposite over hypotenuse. I can ignore the hypotenuse because it's just always 1. Something over 1 is just whatever it is. So this red line here is the opposite. And if I'm looking for sine, I could just look at the length of that red line. And if I'm in quadrant 2, I can look at the length of that red line. Guess what? The adjacent side is this blue side. And so if I want the adjacent for this triangle here, the adjacent over the hypotenuse, I can ignore the hypotenuse and just say, oh, cosine of whatever angle is just the length of the blue line. And I can do this with any of these triangles. So the only thing I have to keep track of now is this extra thing about sines, because think about the x and y axis. X is positive this way and x is negative this way. Y is positive this way and y is negative this way. So as you can see, in quadrant 1, both sine and cosine are positive. In quadrant 2, sine is positive, but cosine is negative. In quadrant 3, sine is negative, cosine is negative. In quadrant 4, cosine is positive, sine is negative. Again, I can just say that the red line or the blue line is sine and cosine because it's all over the hypotenuse, and the hypotenuse is just a 1. And that's what makes the unit circle really easy to look at, because now if I want the sine of 225 degrees or sine of 150 or 120 degrees or 240, if I get these reference angles, which I'll show you in a moment, and I understand whether something's positive or negative, then I can just get the answer and make the adjustment. So let me make sure we write these down. So positive trig functions for quadrant 1, sine theta is positive, cosine theta is positive, right? Because again, this is positive this way and this is positive that way. Well, guess what? Tangent is opposite over adjacent. Well, what's positive over positive? Positive. So that means tangent of theta is also positive, okay? Now, the next part is quadrant 2, right? Sine is positive. Notice cosine is negative. Now, again, tangent is opposite over adjacent, right? Opposite is positive, adjacent is negative from this angle, right? Here's the opposite and adjacent. Well, that means tangent is negative. So the only trig function of the 3 that we just learned is sine. So only sine is positive in quadrant 2. Take a look at quadrant 3. What's the only thing positive there? Well, this is negative. Whoops. Cosine's negative. Sine is negative. Opposite and adjacent's both negative. Well, that means tangent's actually positive because negative over negative is positive. So tangent's actually positive there. And finally, in quadrant 4, cosine, whoops, I keep forgetting my highlighter. Cosine is positive and sine goes down. So that's negative. So that means cosine is positive there. And again, tangent is sine over cosine, opposite over adjacent. So in that case, if one of these is negative, then tangent is negative. And that's why it says all-star trig class. All stands for everything is positive, right? Sine, cosine, and tangent, they're all positive here in quadrant 1. Star represents sine because only the sine function is positive. Cosine and tangent are negative there. Quadrant 3, only tangent is positive because sine and cosine are both negative. And again, tangent is opposite over adjacent. So if negative over negative gets me positive. So only tangent is positive in quadrant 3. And quadrant 4 is cosine is positive because this blue line is positive and the red line is negative. All right. Again, the reason why we can look at it as just a red line or just a blue line is because opposite over hypotenuse is sine and the hypotenuse is 1. So I can just focus on the opposite if my hypotenuse is 1. Okay, and this is called a unit circle because it's a radius of 1 unit. and the radius is the same thing as the hypotenuse of any of these triangles. All right, that's this part of the notes. I'm going to do another video just to do these quick examples on the bottom, and then you'll be able to do your worksheet after this.